So when we got back to the lab after the fires, we actually laid out everything on this table. And as we saw, those laptops, even the hard drives, they looked absolutely terrible. They were burnt to a crisp. So our next steps were to, again, extract all those drives from their enclosures. We inspected them under our vent hood and made sure that the platter surfaces looked good. And on some of them they did, and we were lucky with that. We were able to clean one of the PCBs. And our next steps too were to actually submerge these drives. The reason, again, is that this is so important is that most of the damage that we see that occurs with these drives is when they actually dry. When the moisture that's inside the drive actually starts to dry and evaporate. That leaves a lot of residue, a lot of mineral deposits on the surface of the platters themselves, which in turn causes damage. So by actually submerging this in the deionized water, we're preventing any of that evaporation from happening, and it's almost like putting it in a time capsule so that it's in the same exact state that it was when it was put in here. And before we seal it too, we want to make sure that we get all of the air out, just so, again, we're not having any water leakage, and it's much easier to ship in this fashion. And even before these drives are shipped to a data recovery lab, we want to make sure we double bag them and that we put as much foam packaging to protect them as possible so they're not damaged and we don't lose any of the water in shipment. So now that we got the hard drives back at the lab, we can actually take a look and inspect the platters to see what kind of damage the fire's actually done. So we're going to actually do that in this laminar flow hood so that any air particles actually just get sucked away so the platter doesn't collect any dust in the process, which may cause damage later in the process. So we're going to close the hood up, and we're going to do all our work inside here, especially when we're opening up the drive. As you can tell from the outside of the drive, it looks pretty burnt, but now that we get to the interior hard drive assembly, actually it looks quite pristine. That platter surface looks really, really great. And even if we give it a little spin here, there is absolutely nothing, no debris at all on that platter surface, which is absolutely incredible. If water does penetrate inside of here, what we'll often see is we'll see water damage along the entire surface of the platter. And what happens is it almost gets calcified. So if there's any type of calcium content or mineral content in the water itself that gets inside of here, when it evaporates, it actually leaves behind a lot of residue, and hard mineral damage will happen to the platter surface. But we got lucky with this one where actually it doesn't look like any moisture penetrated the inside. Sometimes what we see too on these fire damaged drives too, so this is a head keeper which keeps the heads in place that spin across or that glide across the top of the surface platter. Sometimes when the heat gets so intense, this will actually melt to the platter surface and it'll actually prevent the motor from being able to turn the platter. And what would happen is we'll actually have to remove this and replace a new head keeper here. So now that we've inspected it, we can see it's pretty pristine. We could actually put the lid back on, and we know that this is actually in pretty good condition considering what it's been through. So it's always really important to take really high quality photos of all of the different parts of the drive, just so that you can have that as a reference. And what this also helps us do is it helps us read the labels on the drive a little bit better. Because one of the important things to know is that we need to know the exact make, model, and even the firmware revision of this drive in case we need donor parts. Because that firmware revision is actually going to have to match exactly for our donor parts that we're going to need for this drive, if we're going to need that. So we can actually see right up here, using the Togarno microscope, the digital microscope, we could see it's a Western Digital 1 terabyte drive. The model is WD100-2FAEX, and we can even have the firmware model revision right here. And the reason that firmware revision is so important is because if we need to find donor parts for this drive, that firmware model is going to have to match exactly for those donor parts to work properly. Another thing that we also see too sometimes is that this drive label will be so damaged in the fire that we can't even read the make, the model, or anything off of it. So actually another thing that we can do is when we go to read the ROM that's on the PCB on here, we can most often we're able to actually see in the actual data that's on that ROM what the firmware model, what the model of the drive is, and the family and the make of the drive is, and even the size. With this drive here, the PCB looks to be incredibly badly fire damaged. So what we're going to try to do is we'll remove the PCB from the hard drive itself. We'll get it in the ultrasonic cleaner to try to remove as much debris and damage as possible, and we'll put it in our drying oven to dry so it's completely dry, and we'll see if it still works. We can actually see the other side of that PCB was mostly protected from a lot of the fire damage. As you can see, it looks pretty pristine. So our next step for this PCB is we're going to put this in our ultrasonic cleaner to try to remove as much debris as possible from the PCB surface. What's nice about the ultrasonic cleaner is it is non-abrasive, so we're not going to damage any of the components that are on the board. Ultrasonic cleaner did not remove quite a bit of the debris that's kind of stuck on here, so we're going to use a little bit more cleaning techniques, and what we're going to do is we're going to use isopropyl alcohol, 99%, with some cotton swabs, just to try to remove some more of that debris that's on the surface there. So we're just going to wet the tip of our cotton swab here with some isopropyl alcohol. Ah, yes, as we can see, look, that's just coming right off, nice and clean. All right, so now that we've got this PCB nice and clean, and we had it rinsed in deionized water, we're going to put it in our drying oven just to remove all of the moisture from it before we actually try to use it. So this is our drying oven here. We're going to have it sit for 24 hours in our drying oven, and we'll be able to test the PCB after that. So what we have here is an NVMe drive from one of the laptops that we burned. But what I see here is like a little bit of solder that's actually, looks like it's melted and come through. So what I want to do with this is actually inspect this with our X-ray machine here. And I'll be able to actually see if that solder is coming from one of the IC chips that are under here, whether it's the controller or the NAND flash. And I'll be able to actually see that on the X-ray machine here. So let's put it in and let's take a look. So this is the X-ray machine that we use to inspect a lot of our electronic components at a more detailed level without actually needing to take apart the device or removing any IC chips. We can inspect the solder balls on it to make sure that there's no bridging. We can see if there's any cracks in any of the dies of the ICs. We can actually see right here, that actually looks like that solder pool most likely occurred because the heat got so hot inside of the laptop that it started to actually melt some of the solder that was on the board. And you can even see it's covering this component here. So what we're going to want to do before we even try to read anything off of this SSD is just make sure that we clean up that big solder ball there, that pool of solder that's formed. Because this could actually, just looking at it, it might short out this component here because it's covering it so much, and it might cause a bridge between some of these other components, and that could actually cause a short circuit and damage more components on the drive. So just to summarize where we are at this point, we've burned the hard drives and their enclosures. We've brought them back to the lab. We've got them under our vent hood so that we didn't expose the platters to anything. We were able to inspect the platters to see if there's any damage from the fire themselves or any water damage that happened from the extinguishing of the fire. And we were able to clean one of the PCBs of one of the hard drives so that we can make sure that that is still functional. So some of our next steps are going to include actually recovering data from these drives now. So some of those steps are backing up the ROM and the service area of the drives themselves, possibly using donor parts just in case some of the heads were damaged during the process of the fire or the cleaning, and actually, coming up with a result of actually getting all of the data off of these burnt drives.